What if everything you knew about Earth vanished beneath an endless blanket of ice? What if the familiar landscapes outside your window transformed into something so alien, so magnificent, yet so terrifying that survival itself became humanity's greatest achievement? Tonight, we're about to witness one of the most extraordinary chapters in our planet's history. At a time when colossal glaciers ruled continents, when magnificent beasts roamed frozen wilderness, and when our ancestors faced challenges that would forge the very essence of human resilience. Welcome to an epoch that lasted millions of years an era so transformative that its effects still pulse through our modern world. This isn't merely about cold weather or seasonal changes. We're talking about a complete planetary metamorphosis that reshaped mountains, carved valleys, drained oceans, and created land bridges between continents. Every breath you take, every landscape you've admired, every migration pattern of animals today, use or bear the invisible signatures of this frozen epoch. Allow yourself to sink into this journey. Whether darkness surrounds you now, or you're seeking peaceful knowledge to accompany your rest, we'll move through this ancient world at nature's own unhurried rhythm. Just as those glacial periods unfolded across millennia without anyone realizing their world was changing, we'll explore this story without rushing, letting each revelation unfold naturally. The most crucial realization is that this wasn't one continuous deep freeze. Instead, Earth experienced rhythmic cycles, extended glacial periods alternating with warmer phases called interglacials. Our planet's climate oscillated like a massive pendulum across tens of thousands of years, triggered by delicate variations in orbital patterns, axial tilt, and rotational wobble. These astronomical dance moves redirected sunlight distribution so dramatically that seas retreated, exposing vast landmasses, while entire biological communities appeared and vanished like waves across geological time. Transport yourself to what would eventually become Northern Europe, North America, or Siberia. No urban skylines pierce the horizon, no familiar forests stretch before you. Instead, a towering wall of ice dominates the landscape, hundreds of meters tall, extending beyond visual limits. The atmosphere carries that distinctive crystalline sharpness of permanent winter, yet this frozen realm teems with extraordinary life. Across these icy plains, herds of woolly mammoths traverse the landscape, their magnificent curved tusks catching whatever dim light penetrates the perpetual haze. Massive ground sloths move deliberately through the Americas, while saber-tooth predators maintain silent vigils in the grasslands, their elongated canines gleaming like carved bone. These weren't scattered survivors clinging to existence. They were thriving populations perfectly adapted to their harsh environment. In regions where ice never established dominance, particularly around the equator, forests and flowing waterways continued supporting diverse ecosystems. Within these warmer refuges, early humans developed increasingly sophisticated survival strategies. They tracked migrating herds, crafted specialized hunting tools from stone and bone, and gathered around precious fires that provided both warmth and social connection. These people possessed no concept of living during an ice age. This was simply reality, the only world they'd ever known. This reveals something profound about deep prehistory. The frozen epoch wasn't uniformly frigid from pole to pole. While northern continents lay buried under massive ice sheets, equatorial regions maintained temperatures suitable for tropical vegetation and desert ecosystems. Life demonstrated remarkable adaptability, relocating, evolving, persevering. The prehistoric Earth wasn't merely colder, it was more dynamic, more contrasted, more alive with possibility than we often envision. Our story predates human existence by millions of years. Earth has consistently alternated between cold and warm phases, each leaving distinctive geological signatures. Scientists reconstruct this history through ice cores extracted from Antarctica and Greenland's deepest layers. These cylindrical samples preserve microscopic air bubbles from ancient atmospheres, creating detailed records spanning hundreds of thousands of years. These cores reveal that glaciation didn't arrive catastrophically. Instead, ice sheets advanced gradually, then retreated, then advanced again like enormous geological tides grinding bedrock into powder. As glaciers expanded, they fundamentally altered underlying terrain. Sharp mountain peaks emerged from grinding ice. Valleys deepened and widened. Massive boulders traveled hundreds of kilometers, deposited like scattered artifacts when retreating glaciers finally released their grip. Modern landscapes across Canada, Scandinavia, and northern United States still display these ancient scars. Lakes occupy depressions carved by moving ice. U-shaped valleys reveal glacial pathways. Rocks sit far from their geological origins, silent witnesses to ice sheet migrations that occurred millennia ago. Ocean levels dropped over 100 meters as countless cubic kilometers of water transformed into continental ice sheets. This dramatic change expanded land masses significantly. A frozen corridor called Beringia connected Asia and North America across what we now know as the Bering Strait. This wasn't merely geographical curiosity, it became a crucial pathway enabling intercontinental migration of both animals and humans, forever altering global population distribution. Standing on that ancient land bridge, fierce winds would sweep across endless tundra, carrying snow that rarely accumulated permanently. Caribou and mammoth herds moved in organized formations, sustaining themselves on hardy grasses that somehow flourished in these extreme conditions. Wolf packs maintained careful distances, their thick pelts protecting against bitter temperatures. Small human groups followed these migrations, wrapped in animal furs, their visible breath marking each labored step toward unknown territories. The interconnectedness was remarkable. Glacial expansion dried the planet because vast quantities of water remained frozen in ice sheets. Desert regions expanded while tropical rainforests contracted dramatically. Where infinite green canopies once existed, open grasslands now stretched across continents. This mammoth steppe environment dominated Europe, Asia, and North America, supporting enormous grazing populations that sustained both predators and increasingly skilled human hunters. Despite its severity, this frozen world constantly evolved. Every few tens of thousands of years, ice retreated, temperatures moderated, and vegetation returned. Rivers swelled, forests regenerated, and grasslands diminished. These temperate intervals proved temporary. Eventually, glaciers resumed their relentless advance, freezing the world once more in predictable cycles. During one such warming period, human societies began flourishing, mastering stone tool technology, creating cave art, and ultimately transcending their Ice Age origins to enter what we call record history. Yet that frozen era's influence never disappeared, remaining embedded in our landscapes, migration patterns, cultural memories, and even our physical adaptations. Understanding our current Earth requires walking backward into that ancient frozen world, observing ice movement and magnificent creatures, while remembering our planet has worn many faces before becoming the one we recognize today. The cold approaches and vast frozen landscapes await our exploration. These microscopic celestial adjustments fundamentally altered sunlight distribution across northern territories. Gradually, summer seasons weakened their warming power. Previously melting winter accumulations began persisting through warmer months. Slowly, this enduring precipitation transformed from temporary snow into permanent ice formations. Visualizing our world before this dramatic shift challenges comprehension entirely. Vast northern land masses flourished with verdant vegetation, dense woodlands and sprawling meadows dominated landscapes. We now associate exclusively with barren tundra. Waterways flowed unobstructed while countless species grazed across territories that today remain perpetually frozen. However, as decades accumulated and successive summers proved insufficient to eliminate previous winter's deposits, a methodical build-up commenced. Layer upon layer, season after season, accumulated precipitation compressed under increasing weight until snow metamorphosed into solid ice. And from these humble origins, initial glaciers emerged, and once their movement began, no force could halt their progress. These colossal ice formations didn't materialize instantaneously. They advanced systematically like conquering forces, progressing incrementally across vast distances. At maximum extent, these glaciers achieved such enormous proportions, they consumed complete topographical features, engulfing peaks and depressions indiscriminately. The Laurentide ice mass sprawled across North American territories, encompassing Canada while penetrating deeply into present-day United States regions. Throughout Europe, the Fennoscandian Glacier blanketed Scandinavian territories and expanded southward, restructuring terrain through overwhelming pressure. Southern Hemisphere highlands across South America and New Zealand similarly supported their own frozen accumulations. Atmospheric conditions transformed dramatically as global temperatures declined, with unprecedented water volumes trapped within ice formations. Oceanic levels decreased substantially, revealing extensive land masses previously concealed beneath surface waters. Powerful winds stripped exposed flatlands, transporting sediment across hundreds of kilometers, depositing substantial accumulations that remain buried beneath contemporary soil layers throughout China and American Midwest territories. Within these arid, turbulent environments, forest ecosystems deteriorated while grassland habitats expanded significantly. Complete biological communities migrated southward, pursuing favorable temperatures. However, Earth operates through complex interconnected systems rather than simple mechanical processes. Climate patterns result from numerous interacting forces, and while orbital variations initiated cooling trends, additional factors influenced ice age development. Volcanic activities released ash and gases into atmospheric layers, diminishing solar radiation and accelerating cooling processes. Ocean systems contributed significantly as current patterns shifted, trapping thermal energy within deeper layers. Eventually, these cooling feedback mechanisms reinforced each other until our planet established conditions vastly different from contemporary climate patterns. Despite frigid conditions, biological systems demonstrated remarkable resilience. Plant communities adapted to harsh temperatures, establishing themselves along glacial margins, while hardy grasses populated expansive steppes. Animal populations followed these adaptations. Woolly mammoths and mastodons, equipped with dense coats and substantial fat reserves against bitter conditions, assembled into massive herds spanning incredible distances. Bison, musk oxen, and reindeer populated open territories, continuously foraging across dry tundra landscapes. Predatory species flourished equally. Saber-tooth cats maintained hidden positions within grassland territories, while dire wolf packs pursued herds across snow-covered expanses. Beyond these magnificent creatures, smaller survivors persisted throughout harsh conditions. Arctic foxes navigated between snow accumulations, migratory birds followed ancient pathways, and rodents excavated tunnels within frozen substrates. Every living organism established specialized survival niches, molded by environmental conditions, where existence demanded constant adaptation, yet provided predictable challenges. Human populations emerged considerably later, but glacial periods had already inscribed permanent modifications across terrestrial surfaces. Expanding ice formations carved profound channels into Earth's crust, pulverizing stone into microscopic particles. When ice eventually retreated, it exposed raw, newly formed landscapes punctuated by lakes and waterways created from meltwater discharge. Certain regions retained enormous accumulations of stone and debris, minus from stain, remnants from prolonged, methodical advancement. These weren't merely aesthetic alterations. They established foundational structures underlying our contemporary world. This epoch simultaneously embodied violence and tranquility. Glaciers moved with unstoppable determination, yet their advancement remained virtually imperceptible within individual lifespans. Mountains yielded beneath their massive weight, yet wildlife could complete entire existence cycles near these ice formations without witnessing measurable movement. This represents deep time's extraordinary scale minus, where planetary transformation unfolds through increments too gradual for immediate observation, yet produces modifications lasting millions of years. Standing beside those early glacial formations would have created distinct sensations, not through sudden weather events or unexpected wind bursts, but through subtle atmospheric density, faint sounds of shifting ice, and infinite stillness across frozen horizons. Skies appeared pale and moisture-free, solar positioning remained low, and landscapes maintained silence except for occasional ice fracturing as formations crept forward. This marked only initial developments. Subsequently, temperatures continued declining, glaciers expanded further, and Earth entered among history's most dramatic periods. Yet this frozen planet retained vitality. It continuously evolved, sculpting landforms, marine environments, and ultimately determining survival conditions for human populations who would master existence within these harsh parameters. Consequently, environmental conditions were established, a planet encased in ice, terrain carved through forces too immense for immediate comprehension, a world where survival required adaptation strategies no previous creature had encountered. From this frozen foundation, Ice Age narratives would genuinely commence, advancing through methodical progressions. During ice's dominion over Earth, terrestrial vastness wasn't the only overwhelming characteristic. Creatures inhabiting these landscapes surpassed anything existing in modern times. This represented an epoch of colossal beings, shaped through unforgiving yet expansive environments, where physical magnitude became essential survival adaptation. Existing within that world would have diminished any observer regardless of their own proportions or nature. Massive herds established initial dominance across these territories. Envision boundless plains, frigid and wind-carved, yet pulsing with constant activity. Woolly mammoths progressed in extended formations, the shaggy pelts undulating like textured drapery, curved tusks, cutting atmospheric currents while excavating through snow-seeking vegetation. These weren't exceptional solitary specimens. They assembled in groups numbering dozens, occasionally reaching hundreds, traversing steppes, pursuing sustenance sources. Their impressions penetrated deeply into hardened surfaces, creating pathways extending across vast distances. Accompanying these giants, mastodons roamed, stockier relatives of mammoths, their compact limbs and straighter tusks, adapted for mixed woodland environments clinging to glacial plain peripheries. They systematically stripped branches and bark through persistent effort, depleting territories completely before advancing towards subsequent sheltered groves. However, mammoths and mastodons represented merely portions of this frozen procession. Grasslands themselves teemed with bison populations. Their powerful shoulders and thick fur provided protection against piercing winds. Musk oxen, compact and broad-built, gathered into defensive formations when predators approached. Reindeer, ancestral caribou species, migrated continuously, their hooves creating rhythmic percussion against hardened ground, sounds as ancient as the glaciers themselves. Predatory species maintained pursuit patterns. Dire wolves stalked herd boundaries, exceeding modern descendants in size and strength, their dental structures designed for crushing bone matter. Saber-tooth cats, equipped with elongated curved fangs, waited concealed among sparse vegetation, prepared to attack prey significantly exceeding their own proportions. Cave lions prowled these territories as well, leaner yet nearly double the mass of contemporary lions, coordinating hunting strategies across steppes that could challenge the most imposing prey species. These weren't random attacks, but calculated group efforts targeting creatures that individually outweighed entire modern predator families. Dominating this already formidable and spectacular landscape stood the glaciers themselves. These colossal frozen rivers commanded distant horizons like crystalline barriers, their vertical surfaces fractured with profound azure crevasses that seemed to penetrate the planet's core. Movement occurred gradually, yet their commanding presence remained undeniable across vast territories. Atmospheric conditions near these formations carried penetrating cold that sliced through even the densest protective fur. Each fracturing sound of shifting ice reverberated across miles, producing deep resonances that reminded every living organism of immense power positioned just beyond immediate reach. Despite their overwhelming dominance, these glacial masses weren't motionless monuments. They progressed and withdrew, grinding across continental surfaces, scraping away topsoil while restructuring underlying geological foundations. Where these frozen giants passed, they exposed naked bedrock, polished clean through slow yet merciless pressure. They excavated valleys that subsequently filled with waterways and lakes. They constructed cliffs and elevated formations that determined animal migration routes, compelling species into unexplored territories, while simultaneously creating fresh opportunities for predators tracking them. Within shadows cast by these glacial behemoths, biological systems demonstrated persistence. Adaptation occurred through methods that appear nearly impossible by contemporary standards. Many magnificent Ice Age species developed substantial fat layers beneath their hide coverings, providing insulation against severe cold conditions. Their coat systems weren't merely surface fur, but intricate underlayers of wool, so fine that thermal energy remained trapped close to skin surfaces. Even their circulatory systems differed fundamentally. Certain species evolved enhanced thermal distribution capabilities, maintaining limb warmth despite the harshest wind conditions. Blood chemistry adapted specifically for extreme temperature survival, allowing these creatures to thrive where modern animals would perish within hours. Human populations also mastered coexistence alongside these giants. For our predecessors, mammoth presence represented not merely danger but essential survival resources. Their skeletal structures provided construction materials for shelters. Hide coverings became protective clothing systems. Meat supplied crucial calories, enabling small hunting groups to endure environments where sustenance remained scarce and darkness extended through lengthy, bitter periods. The Ice Age world's sheer magnitude could diminish any individual existence. Single glaciers extended across hundreds of miles. Mammoth herds required multiple days to traverse from one visible horizon to another. Even atmospheric conditions appeared more expansive, with pale illumination reflecting off snow and ice formations extending in every direction without interruption. This wasn't an environment designed for comfort or convenience. It demanded extraordinary endurance from every inhabitant. In exchange, it forged creatures both human and animal into survivors possessing remarkable resilience capabilities that transcended anything we observe in modern ecosystems. Standing upon those frigid, wind-swept territories would have revealed Earth in one of its most pristine, uncompromising forms. Atmospheric sharpness sufficient to create physical discomfort. Distant glacial shifting sounds resembling groans from ancient, massive creatures. Visual experiences of animals exceeding house dimensions, moving in deliberate, measured formations across endless horizons. Every environmental aspect conveyed planetary transformation through forces extending far beyond any individual creature's influence or control, yet balance existed within this harsh system. Glaciers advanced, then retreated in predictable cycles. Giants flourished but also succumbed to skilled hunters or disappeared into snow when resources became insufficient. Biological persistence occurred not through conquering cold conditions, but through learning coexistence within them. As our world progressed through these frozen millennia, this delicate balance faced continuous testing. Climate patterns shifted unpredictably. Ice yielded to warming periods, then returned. Animal populations migrated, adapted, or vanished entirely. Throughout these transformations, human communities continued learning, observing, and following Earth's slow choreography alongside its icebound giants. Moving deeper into this frozen history, attention shifts toward the mechanism driving these extraordinary events. Complex, detailed atmospheric modifications set every development into motion throughout this remarkable epoch. Cold conditions never maintained consistency. Even during peak Ice Age periods, Earth wasn't secured within unchanging freeze patterns. Our planet breathed rhythmically. Across tens of thousands of years, temperatures elevated and declined, like gradual tidal movements. With each fluctuation, glacial formations advanced or withdrew, continuously reshaping landforms and dependent biological systems. Understanding this world requires more than visualizing snow-buried territories. We must comprehend how that snow moved, how cold intensified then diminished, and how these extended, quiet transformations composed the Ice Age narrative. Central to this rhythm were cycles scientists can still trace. Currently, researchers identify them as Milankovitch cycles, named after the mathematician who initially calculated their patterns. These result from Earth's movement around our sun near, not through perfect circular paths, but via prolonged, slow orbital dance, changing across tens of thousands of years. Our orbital shape stretches and contracts cyclically. Earth's axial tilt varies slightly more than slightly less. Even planetary wobble, resembling a spinning top losing momentum, shifts sunlight distribution reaching different global regions. Each movement occurs too gradually for any single generation to detect, yet collectively they transform everything. When tilting decreases, northern hemisphere summers become cooler. Winter snowfall persists longer into subsequent years, and ice accumulates. When tilting increases, summers strengthen and warm more intensively, melting additional snow while ice formations retreat. This represents balance, subtle yet relentless, converting planetary conditions from cold to less cold, then back again across immense temporal stretches. However, orbital changes alone cannot explain complete ice age intensity. Earth's climate operates as interconnected feedback networks, where individual small shifts trigger additional responses. When glaciers expand, they reflect increased sunlight into space, cooling the planet further. Colder conditions cause oceans to absorb more carbon dioxide, securing it away while reducing atmospheric greenhouse gases. That carbon dioxide reduction cools the world, additionally helping ice spread across greater distances. This creates chain reactions requiring millennia to establish and even longer periods to reverse direction. Yet these cycles operate bidirectionally. When Earth begins warming, opposite effects occur. Ice melts, exposing dark soil and open water surfaces that absorb increased thermal energy. Oceans release carbon dioxide back into atmospheric systems, trapping additional warmth. Feedback loops reverse direction and glaciers retreat systematically. Our planet doesn't simply fall into ice ages or escape from them abruptly. It oscillates between these states like massive pendulum movements, steady in their timing, yet immense in their scale and consequences. Even within these grand cycles, smaller disruptions occurred. Sudden temperature pulses, either cold or warm, rippled across ice age environments. Some originated from ocean systems, as vast current patterns shifted pathways, redistributing thermal energy between equatorial and polar regions. Others were triggered by massive volcanic eruptions, sending ash and sulfur compounds into atmospheric layers while dimming solar radiation for years continuously. At great ice sheet peripheries, enormous lakes sometimes formed behind frozen water barriers. When those icy dams collapsed, they unleashed flooding so extensive that coastlines were rewritten and climate patterns potentially shifted for centuries. Experiencing these changes meant witnessing the world gradually tilting from balance before settling again. For animals roaming steppes and forest environments, it required following terrain as it transformed. Mammoth and bison herds pushed southward when cold intensified, only to expand northward again when ice withdrew. Predators followed their prey species. Early human communities, small hunter-gatherer bands, learned interpreting these patterns within landscapes, moving with seasonal changes and shifting boundaries of cold regions. Glaciers themselves recorded these fluctuations in silent detail. Every ice layer contains microscopic bubbles of ancient atmospheric conditions trapped as snow accumulated and compressed year after year. When scientists extract cores from these deep layers, they observe planetary breathing patterns. They discover fingerprints of every advance and retreat, every sharp temperature drop or sudden warming event. Within that frozen archive, Ice Age history remains preserved, stacked one winter above another, creating libraries of deep time containing detailed environmental records spanning hundreds of thousands of years. Reading about these rhythms differs significantly from imagining their reality. Consider standing upon wide, cold plains with pale skies and cutting winds. Far northward, ice walls loom like mountain ranges. For centuries they've crept forward mile by mile, slow invasions no living observer could detect. Then, after thousands of years, atmospheric conditions warm. Summer seasons extend their duration and intensity. Glacial boundaries commence their withdrawal. Water cascaded from beneath these formations, excavating fresh waterways. Territories once entombed beneath ice lay exposed, unprocessed, and receptive to solar radiation for initial occasions across countless ages. Eventually, frigid conditions returned, initiating another prolonged ice advancement. This represented the Ice Age's respiratory pattern, gradual, consistent, yet possessing sufficient power to sculpt continental masses. Rather than single freezing episodes or isolated thaws, this constituted an extensive methodical cycle, one that challenged biological systems to their absolute limits before allowing recovery periods. Throughout that extended oscillation, animal species evolved, human communities adapted, and Earth transformed into the world we still recognize, despite extensive changes vanishing beneath contemporary warmth. However, Ice Age narratives encompass more than temperature fluctuations. They concern living ecosystems that developed within that frozen illumination. While climate established environmental conditions, biological systems themselves, extraordinary, massive, and resilient, provided the Ice Age its distinctive character. Beneath perpetual cold and sweeping icy plains, biological systems persevered. They didn't simply await warmer periods' return. Instead, they adapted, evolved, and established territories within Earth's harshest known environments. Surviving frigid conditions required more than mere endurance. It demanded complete transformation, from microscopic insects concealed beneath snow to enormous creatures traversing frozen steppes. Ground surfaces during Ice Age periods weren't devoid of life. Just beneath snow layers existed hidden worlds, constructed on miniature scales. Within tundra soils, rodents excavated tunnel networks. Their compact bodies were protected by earth and frost barriers. Lemmings, voles, and additional small mammals formed food chain foundations. Their survival enabled countless predatory species above them. These creatures didn't hibernate completely. Many remained active beneath snowpack layers, their movements carved passages invisible from surface levels. Within these spaces, atmospheric conditions remained still, temperatures stayed stable, and overhead snow provided insulation against severe winds. Above them, larger animals traversed landscapes with heavy, purposeful steps. Woolly mammoths, enveloped in coats of lengthy, coarse hair with dense, insulating wool underlayers, could withstand temperatures that would freeze exposed skin within minutes. Their blood carried specialized adaptations, enabling oxygen release even in their body's coldest regions, preventing limb stiffening. Musk oxen possessed thick pelts, so effective that snow could accumulate on their backs without melting evidence that virtually no thermal energy escaped. Predators demonstrated equal preparation. Dire wolves and saber-tooth cats were constructed for strength and endurance, with powerful muscular systems for bringing down prey in deep snow. Their coats remained thick, while their paws were broad enough to prevent sinking into frozen surfaces as they pursued quarry. Even magnificent cave lions, among history's largest feline species, were shaped by cold conditions. Leaner than modern relatives, yet equipped with limbs designed for endless pursuit of Ice Age prey across open territories. Plant life supporting this frozen world proved equally remarkable. Initially, Ice Age landscapes might appear barren, but just beneath snow and during brief summers, hardy vegetation flourished. Grasses dominated mammoth steppes, covering vast areas from Europe to North America. These grasses contained rich nutrients, perfectly suited for grazing herds requiring nearly constant feeding to survive cold conditions. Intermixed among them grew tough shrubs and dwarf willows, their branches remaining close to ground levels, protected from relentless winds. These plants evolved to withstand extended darkness periods and brief, intense growth seasons, responding rapidly to short summer sunlight windows. Even insects discovered survival methods. Some produced natural antifreeze within their bodies, proteins preventing cellular freezing. Others laid eggs capable of surviving winters untouched, awaiting brief summer warmth to awaken subsequent generations. Birds adapted similarly. Many species migrated southward, but some remained, their feathers dense, their metabolisms burning sufficiently hot to endure deep cold. Snowy owls, for example, patrolled tundra year-round, feeding on lemmings and thriving in environments few others could tolerate. Humans, though comparatively fragile, weren't without their own strategies. Early hunters and gatherers relied on ingenuity equally with strength. They fashioned clothing from furs stitched tightly to trap thermal energy. They constructed shelters from bone and hide, using mammoth ribs as tent frames covered in thick animal skin layers. Fire became their greatest ally, not only for warmth but for survival itself, allowing them to cook food, harden tools, and push back against deep, unrelenting darkness. For these small human groups, existence represented constant negotiation with cold conditions. Every step into snow carried risk. Frostbite, hunger, and predators created daily threats. Yet they learned moving with seasonal patterns, following herds during migrations, using rivers and coastlines as landmarks across endless white expanses. They created weapons from stone and bone, sharp enough to pierce thick hides of hunted beasts. Over time, their knowledge of this frozen world deepened, until they could live not despite cold conditions, but because they understood them. What made this hidden biological network remarkable was its balance. The snow didn't simply bury the world, it shaped it. Beneath its weight, species learned bending without breaking. Each adaptation, from smallest vole tunnels to mammoth insulating coats, responded to environments demanding everything while providing little in return. Yet this world encompassed more than survival. It also involved transformation. With every climate swing, with every glacial advance or retreat, biological systems shifted, species thriving in cold, sometimes vanished when worlds warmed. Others emerged, occupying abandoned niches. The Ice Age wasn't a frozen prison. It was a crucible, producing creatures and behaviors still echoing in contemporary living systems. Even now, in Siberian tundras or Arctic Circle regions, fragments of those ancient survival strategies remain visible. Musk oxen still stand broad and immovable against winds. Arctic foxes still change coat colors from brown to white, seasonally vanishing into snow like phantoms. These living remnants remind us that ice ages didn't end cleanly. They scattered pieces of themselves across Earth, pieces that still endure. As glaciers breathed in and out, as cold deepened and eased, this hidden world beneath snow never stopped changing. What lay ahead was a planet still in motion, where ice would carve terrain in ways reshaping Earth's very foundations. Ice was never motionless. It moved with force so vast and unrelenting that entire continents were reshaped. When we visualize glaciers, we often imagine silent walls of frozen whiteness. But these great ice sheets weren't static monuments. They were transformation engines, grinding, crushing, and carving underlying terrain with patience only Earth itself can maintain. The most colossal glacial formations blanketed extensive portions of the northern hemisphere. Throughout North America, the Laurentide ice mass extended from high Arctic territories southward to present-day central United States regions. These formations achieved such extraordinary thickness that their surfaces elevated above the tallest mountain peaks. Across Atlantic waters, the Fennoscandian ice sheet encompassed Scandinavian territories while penetrating deeply into northern European regions, its boundaries advancing gradually like tides of crystallized stone. Even within southern hemisphere territories, smaller ice formations covered highland areas across South America, New Zealand, and Antarctic sections, extending farther than contemporary boundaries. These ice masses weren't gentle forces. During advancement periods, they stripped Earth's surface completely bare. They eliminated forest systems, demolished hills, and pulverized rock formations into microscopic particles. Beneath their overwhelming weight, planetary crust itself bent downward, sinking measurably under such enormous loads. When ice subsequently retreated, terrain rose again through slow rebounds, continuing even now throughout Canadian and Scandinavian regions. This represents geological memory. The Sith, still recovering from pressures applied thousands of years previously. Glacial movement created landscapes remaining easily recognizable today, profound valleys featuring flat bottoms and steep walls, carved through relentless pressure from moving glaciers, appear across northern territories worldwide. Enormous boulders transported across hundreds of miles before being deposited far from original sources, sit scattered throughout open fields, silent witnesses to journeys they once completed while trapped within ice formations. Lakes represent another glacial legacy. Thousands of them fill basins excavated by these frozen giants. North America's Great Lakes exemplify this phenomenon, most famously Mai's vast water bodies, resting within scars left by the retreating Laurentide ice sheet. These weren't merely accidental depressions, but systematically carved basins that would later support entire ecosystems and human civilizations. Glaciers weren't only terrestrial sculptors, they simultaneously shaped global water systems. As ice accumulated, oceanic levels declined dramatically, exposing extensive coastal plains previously hidden beneath waves. When ice melted, seas rose again, submerging those same territories beneath returning waters. land bridges connecting continents, such as the corridor linking Asia to North America, existed exclusively because planetary water remained locked within ice formations. Each glacial shift rewrote Earth's geographical configuration entirely, yet despite their tremendous power, glaciers moved gradually. Mere feet daily constituted sufficient force to transform continental faces completely. Standing before such formations meant confronting forces appearing eternal, despite constant motion. Auditory evidence of their presence occasionally emerged: sharp fracturing sounds of shifting ice, low groaning of frozen masses pressing against terrain. When meltwater accumulated, then suddenly broke free, it surged across landscapes in floods so massive they carved fresh channels within days. These weren't gentle waterways. They attacked terrain with strength accumulated from centuries of trapped water suddenly unleashed. Paradoxically, despite their destructive capacity, glaciers simultaneously created fresh opportunities for biological systems. When they retreated, they revealed newly exposed ground stripped clean yet enriched with mineral dust. Plant communities rapidly colonized these barren landscapes, establishing root systems within raw earth. Subsequently, animal populations followed, and human hunters tracked herds into territories glaciers had recently uncovered. These frozen sculptures preserve stories within their layered structures. Within ice formations themselves, scientists discovered traces of ancient atmospheric conditions, ash from distant volcanic eruptions, and pollen from plants that flourished ages ago. Each layer constitutes a record mired pages within Earth's frozen history, revealing not only how ice shaped terrain, but how it responded rhythmically to climate patterns. For creatures experiencing these periods, however, glaciers weren't historical phenomena. They represented boundaries massive and seemingly immovable. To mammoths or bison, glacial edges marked world's end, masked walls that couldn't be crossed. Even humans, despite cleverness and determination, could only traverse along their borders, following rivers and valleys where ice hadn't claimed territory. As ice sheets expanded and contracted through slow planetary pulses, they drafted maps of our contemporary world: every rolling hill throughout northern Europe, every scattered lake across Canada, every stretch of fertile soil within American Midwest territories bears glacial signatures. These weren't simply frozen water masses. They were chisels that carved Earth itself, leaving permanent modifications that continue influencing modern landscapes, weather patterns, and biological distributions. When magnificent ice sheets expanded and secured vast quantities of planetary water, oceans withdrew like tides, refusing to return for millennia. Shorelines extended outward dramatically, exposing enormous plains concealed beneath waves for ages. Rivers carved fresh pathways across newly uncovered ground, while entire continents gained additional edges. The world appeared different, familiar in fundamental shape, yet altered through methods seeming nearly impossible to envision now. At Ice Age peaks, sea levels dropped more than 100 meters. This wasn't sudden plunging, but gradual withdrawal, paced by relentless glacial growth. Previously, shallow coastal waters transformed into windswept grasslands. Bays and inlets became dry valleys. Islands connected to mainlands, and land bridges materialized between continents today divided by open seas. Thuringia stands as the most renowned example, a terrain stretch once connecting Asia and North America. Rather than narrow strips, this constituted enormous tundra and steppe expanses, hundreds of miles wide, dotted with rivers and supporting mammoths, bison, and initial human populations who would eventually cross into new worlds. For those traversing it, this wasn't a bridge at all. It was landscape mish, a distinct country, rich with biological diversity and as genuine as any other Earth region. Farther south, the Sunda Shelf joins Southeast Asian islands to mainland territories, creating vast continuous landmasses. Australia, New Guinea, and Tasmania merged into single connected continents. Throughout Europe, North Sea floors were exposed, forming regions now known as Doggerland Broad Plains, stretching between Britain and continental Europe, crisscrossed by waterways and dotted with low hills. These new territories didn't merely alter geography, they transformed life's trajectory entirely. Animal populations followed expanding frontiers, migrating into places where seas had previously blocked passage. Human communities pursued similar patterns, tracking game across these fresh pathways while slowly spreading globally through methods that would shape our species' future development. However, this transformation extended beyond terrestrial changes alone. Ocean retreat reshaped remaining coastlines dramatically. Beaches extended outward for miles. Estuaries contracted significantly. Coral reefs were abandoned high and dry, bleaching and perishing as waters deserted them. Marine ecosystems compressed into smaller areas while adapting to completely different conditions. These exposed continental shelves revealed landscapes that had remained submerged for millions of years. Ancient riverbeds became visible, showing where prehistoric waterways once flowed before being drowned by rising seas during earlier warm periods. Fossilized remains of terrestrial plants and animals were discovered in areas that had been ocean floor, providing evidence of how dramatically coastlines had shifted throughout geological time. The newly exposed lands quickly developed their own ecosystems. Hardy grasses and shrubs colonized the former seafloor, creating vast steppes that extended the existing mammoth steppes even further. These areas became crucial migration corridors, allowing species to move between previously isolated continents and leading to one of the most significant biological exchanges in Earth's history. For early human populations, these land bridges represented pathways to entirely new worlds. Small bands of hunters following migrating herds found themselves in territories no human had ever seen before. They carried with them not just their tools and knowledge, but also their cultures, languages, and genetic heritage, seeding new continents with human presence that would eventually flourish into complex civilizations. The effects of this oceanic retreat rippled throughout global climate systems as well, with less surface water to moderate temperatures and with vast new land masses exposed to direct atmospheric influence. Weather patterns shifted dramatically. Continental climates became more extreme, with hotter summers and colder winters in many regions. Wind patterns changed as air masses encountered different topographical features, altering precipitation patterns across the globe. Ocean currents, too, were forced to find new pathways. The massive circulation systems that had previously flowed across now exposed shelves had to redirect through deeper channels, fundamentally altering how heat was distributed around the planet. These changes in ocean circulation created feedback loops that influenced the very glacial systems responsible for the sea level drop in the first place. Marine life faced unprecedented challenges as their habitats compressed into smaller areas. Species that had evolved in shallow coastal waters found themselves forced into deeper environments or eliminated entirely. However, this compression also led to increased competition and evolutionary pressure, driving rapid adaptation and speciation in marine ecosystems. Meanwhile, the exposed continental margins became some of the most productive terrestrial environments on Earth. The nutrient-rich sediments that had accumulated on the ocean floor over millions of years now supported incredibly fertile grasslands. These areas could sustain enormous populations of grazing animals, which in turn supported large predator communities and eventually human hunters. The transformation was so complete that if a modern observer could somehow view the Ice Age world, they would struggle to recognize familiar coastlines. The Mediterranean Sea was smaller and nearly enclosed. The Persian Gulf was entirely dry land. The English Channel didn't exist. Britain was connected to continental Europe by hundreds of miles of rolling plains and forests. This wasn't merely a temporary geographical quirk, but a fundamental reorganization of the planet's surface that lasted for thousands of years. Entire generations of plants, animals, and humans lived their complete life cycles on lands that would eventually return to the ocean floor. Their stories, their struggles, and their achievements played out on stages that no longer exist above water. As we trace these ancient shorelines and imagine the vast landscapes that once connected continents, we begin to understand that the Ice Age wasn't just about cold and ice. It was about a planet so transformed that the very shape of the world was different. The ice didn't just freeze the existing world, it revealed an entirely new one, hidden beneath the waves and waiting for the right moment to emerge into the light. Global oceanic systems underwent profound transformations, becoming both colder and more saline as their circulation patterns shifted in response to altered water and ice equilibrium. These modifications created powerful feedback mechanisms that reinforced Earth's frozen condition effectively locking the planet into its glacial state for extended periods. Even atmospheric conditions above marine environments experienced dramatic changes. As oceans retreated, enormous expanses of exposed continental shelves transformed into dust sources. Powerful ice age winds swept up these particles, transporting them across thousands of miles before depositing them over distant land masses. This aerial sediment accumulated into thick, nutrient-rich layers that would eventually support some of Earth's most productive agricultural regions. This phenomenon serves as another reminder that the Ice Age represented not merely destruction, but preparation needed to establishing foundations for post-glacial civilizations. However, for contemporary inhabitants, these transformations remained largely imperceptible. Marine boundaries didn't disappear instantaneously. Individual hunters could traverse identical paths their ancestors had walked, completely unaware that distant waters were gradually receding year after year. Only across generational timescales did these modifications become apparent. Lives of rivers flowing where bays once existed, herds grazing on former ocean floors, and fresh horizons beckoning adventurous explorers. While oceans remained stationary, biological systems demonstrated remarkable adaptability. Coastlines evolved into hunting territories. River mouths transformed into abundant feeding grounds for migratory birds and fish populations. Human communities learned exploiting these environmental changes advantageously, following animal trails now traversing exposed plains. Throughout every Ice Age region, retreating waters revealed not simply terrain, but unprecedented opportunities for expansion and survival. Yet, like glacial formations themselves, oceanic conditions wouldn't remain permanent. As climate patterns eventually warmed, ice would begin retreating and seas would advance again, submerging territories they had abandoned. Doggerland would sink beneath North Sea waters. Beringia would vanish beneath Bering Strait currents, and global coastlines would return to configurations resembling contemporary geography. However, that transformation remained distant. During Ice Age peaks, oceans had paused their eternal motion. Our planet maintained its frozen equilibrium, secured an ice and sea balance that sustained this condition across thousands of years. Within this crystalline stability, great atmospheric winds commenced rising, carrying their sediment burden across skies, while marking the next major force shaping this ancient world. Cold temperatures alone didn't characterize the Ice Age completely. Alongside glacial formations and diminished seas, emerged skies heavy with particulate matter and winds that seemed perpetually restless. Atmospheric conditions during this epoch differed dramatically from clear, crisp air we might envision when visualizing frozen worlds. Instead, fine particles traversed continents continuously, rendering sunlight hazy while painting skies in pale, muted hues. This dust originated from territories ice had abandoned. When glaciers advanced, they pulverized underlying bedrock into microscopic powder. As ice retreated or stalled along boundaries, winds swept across these barren plains, lifting finest particles into atmospheric currents and driving them across hundreds, even thousands of miles. Each storm system contributed additional sediment, spreading blankets of dust that settled far from original sources. Throughout numerous regions, these accumulations persist today. Losses deposits, as scientists identify them, extend across China, European territories, and North American landscapes. These formations reach hundreds of feet in thickness across certain areas, constructed grain by grain from Ice Age wind systems. Eventually, these dusty plains would develop into Earth's most fertile soil systems. However, during glacial periods themselves, they participated in endless cycles of wind, dust, and relentless cold. Weather patterns transporting this sediment proved harsh and unpredictable. Vast temperature differentials between frozen northern territories and moderately warmer southern regions generated powerful wind systems. These currents scoured landscapes, compressing snow into hard-packed surfaces while eliminating whatever minimal warmth could be discovered. They transported not only dust but snow, accumulating it into drifts capable of engulfing complete topographical features. Yet Ice Age atmospheric conditions represented more than wind and dust environments. They constituted worlds of extremes. Winter seasons extended lengthily with bitter temperatures plunging far below anything most contemporary individuals could comprehend. Summer periods, though brief, could prove surprisingly warm across certain regions, particularly throughout great grasslands where solar radiation faced minimal cloud competition. These sharp seasonal contrasts created environments where biological systems required endless adaptability, capable of enduring deep freezing periods, then bursting into activity during brief growth and abundance windows. This environmental oscillation shaped every aspect of life, from microscopic organisms to massive megafauna, forcing evolutionary adaptations that prioritized flexibility over specialization. Volcanic activities contributed additional chaos to these already unusual atmospheric conditions. Massive eruptions released ash into atmospheric layers, blocking solar radiation and intensifying cold periods for years continuously. Within certain ice core strata, scientists have discovered traces from these ancient eruptions, fingerprints marking moments when skies darkened significantly, providing glaciers opportunities to advance even further southward. Even atmospheric composition differed fundamentally from contemporary conditions. Carbon dioxide concentrations during Ice Age periods remained far lower than current levels. This diminished greenhouse effect rendered atmospheres colder and more arid, particularly near massive ice sheet formations. Throughout these regions, snowfall occurred infrequently, not because extreme cold prevented precipitation, but because atmospheric moisture remained so scarce. Paradoxically, frozen cores of Ice Age worlds often resembled snow and wind deserts, their surfaces scoured rather than buried beneath fresh accumulations. This created unique environmental conditions where traditional expectations about cold climate precipitation patterns didn't apply, forcing adaptations among both plant and animal communities. For animals inhabiting these worlds, weather patterns weren't temporary concerns, but fundamental forces shaping every behavioral decision. Mammoth and bison herds followed shifting wind patterns to locate areas where snow had been cleared, exposing underlying vegetation. Predatory species trailed these herds, their survival depending entirely on understanding these same meteorological patterns. Even early human populations learned interpreting atmospheric signals, observing wind directions and cloud formations to predict weather shifts and anticipate periods of intensifying cold. This environmental literacy became essential survival knowledge, passed down through generations and refined through countless seasonal cycles. Dust transportation carried its own ecological consequences. While particulate matter dulled skies and coated ground surfaces, it simultaneously nourished biological systems. Wind patterns distributed nutrients across plains, scattering mineral deposits that rendered Ice Age grasslands unexpectedly productive. This created one of the Ice Age world's most intriguing paradoxes: manospheres filled with dust and perpetual winds, yet supporting landscapes capable of sustaining enormous grazing populations. The dust itself told stories of distant landscapes. Particles originating from Saharan regions could travel thousands of miles northward, carrying chemical signatures that modern scientists can still identify in ice core samples. Similarly, volcanic ash from eruptions in one continent could influence weather patterns across entirely different hemispheres, demonstrating the interconnected nature of Ice Age atmospheric systems. These atmospheric conditions also influenced human technological development. The constant wind exposure necessitated sophisticated shelter construction techniques, using available materials, mammoth bones, animal hides, and carefully positioned stone arrangements. The perpetual dust required innovative food storage methods to prevent contamination, while extreme temperature fluctuations demanded versatile clothing systems capable of adaptation across rapidly changing conditions. Perhaps most significantly, these atmospheric patterns helped regulate the Ice Age's duration and intensity. Dust-laden skies reflected incoming solar radiation differently than clear atmospheres, contributing to cooling effects. Simultaneously, dust deposition on ice surfaces could accelerate melting by darkening reflective surfaces, creating complex feedback mechanisms that influenced glacial advance and retreat cycles. The interaction between atmospheric dust, wind patterns, and temperature extremes created unique optical phenomena. Sunrises and sunsets during Ice Age periods would have displayed extraordinary color ranges as light filtered through particle-laden air. Aurora displays, enhanced by different atmospheric compositions, likely appeared more frequently and intensely, particularly during periods of heightened volcanic activity. These atmospheric conditions persisted for thousands of years, creating environmental pressures that shaped evolution across multiple species simultaneously. The combination of temperature extremes, constant wind exposure, and dust-laden air selected for organisms capable of thriving under stress, while maintaining flexibility for rapid environmental transitions. Understanding these atmospheric dynamics helps explain why Ice Age ecosystems, despite their harsh conditions, supported such remarkable biodiversity. The constant environmental challenges prevented any single species from achieving complete dominance while rewarding adaptability and resilience, qualities that would prove essential as Earth eventually transitioned away from its frozen state toward the more temperate conditions we recognize today. Ribs, tusks, and skulls were assembled into structural frameworks, then covered with animal hides, constructing dwellings capable of excluding even the most severe winter atmospheric conditions. Interior spaces remained confined yet warm, illuminated by a single essential life force: fire. Fire transcended mere utility. It represented the boundary separating survival from death. Around its luminescence, families clustered together, their fur garments pulled securely, hands extended toward radiating warmth. It processed their sustenance, strengthened their weapons, and provided protection against Ice Age night's perpetual darkness. A solitary flame could signify safety within environments where cold waited beyond walls, patient and merciless. However, fire alone proved insufficient. Human populations learned shaping stone into blades, scrapers, and spear points sharp enough to penetrate mammoth and bison hides. They crafted implements from bone and antler materials. Each tool was designed with precision born from absolute necessity. Hunting within these conditions wasn't simple activity. It demanded cooperation among small groups working collectively to track prey across open terrain, driving animals into ambush positions, or toward waiting hunters armed with spears. Single successful hunts could sustain numerous individuals, while failed attempts meant days of starvation. Even within frigid conditions, they discovered creative expression methods. Throughout caves and shelters scattered across European and Asian territories, they left paintings and carvings behind. Mammoths, bison, horses, and reindeer adorned walls, drawn with careful attention to details, suggesting profound familiarity with their subjects. These weren't merely decorative elements. They may have served educational purposes, memorial functions, or expressions of hope, evidence that even within worlds where daily existence required constant struggle, space remained for something beyond mere survival. Clothing systems also represented adaptive responses. Early humans stitched furs together using bone needles, layering garments until cold could no longer penetrate. Boots lined with grass and hide materials protected feet from freezing on icy surfaces. Each clothing piece reflected accumulated experience refined across generations of experimentation until they could confront wind and snow while maintaining mobility. Cold conditions demanded relentless innovation. Every tool, shelter, and fire gathering represented responses to fundamental questions about existence within these environments. Gradually, humans learned thriving where unprepared individuals would have perished. They observed animals, studying migration patterns and territorial usage. They followed herds toward fresh grazing areas, consumed water from rivers carved by melting glaciers, and mapped territories not through written symbols, but through memory systems. During lengthy nights, they shared stories around fires while winds howled beyond their bone and hide barriers. Voices carried through darkness, speaking of hunts, confronted dangers, and the strange, immense world surrounding them. These narratives served purposes beyond comfort. They transmitted knowledge systems, teaching subsequent generations survival techniques within territories where individual mistakes could prove fatal. Yet even within these unforgiving environments, moments of quiet connection occurred, fires crackling within darkness, children curled against mothers warm beneath fur layers, soft voice harmonies blending with external wind sounds. During these moments, the Ice Age represented more than endurance tests. It became environments where humans began shaping themselves into adaptable, resilient beings they would eventually become. They weren't isolated within this frozen world. Other human populations, including Neanderthals, shared identical harsh landscapes temporarily. They similarly mastered cold conditions, constructing their own shelters and hunting identical herds. Some groups possibly exchanged tools or joined together, leaving interconnected life traces still echoing within our genetic material. Within deep prehistory, beneath pale Ice Age sunlight, boundaries between survival and innovation began blurring, and humanity's future developed slowly through firelight and shadow. These weren't bustling urban centers or magnificent civilizations from later periods. These were small human clusters bound through necessity, shaped by territories they traversed. Every step, choice, and fire spark, ignited within snow, represented portions of gradual forward progress. Quiet determination to exist within worlds, seemingly designed to repel them. As fires burned against darkness, external cold never truly relented. Ice still dominated horizons. Winds still transported dust across plains. Yet within those fragile warmth circles, humans persevered. Through perseverance, they began transforming worlds through methods that would outlast Ice Age periods entirely. Cold wouldn't destroy them, it would forge them, and through that forging process, they would initiate everything following afterward. Within fire's glow, with winds pressing against shelter walls, humans began accomplishing more than mere endurance. They learned shaping worlds through manual dexterity. Every tool chipped from stone, every line drawn upon cave walls, represented additional steps toward mastering Ice Age conditions rather than simply surviving them. Stone became their most reliable resource. From riverbeds and cliff faces, they collected flint and chert materials, fracturing them through deliberate strikes to produce sharp cutting edges. Initial tools were simple flakes for hide scraping or meat cutting, but across generations they achieved greater refinement. Hunters learned crafting lengthy, narrow blades attachable to spears, transforming them into weapons capable of bringing down steppes' largest animals. They shaped bone and antler into barbed points and hooks, tools designed for precision rather than brute force applications. These weapons transcended survival instruments. They proved growing abilities to anticipate problems, imagining solutions before requirements arose. Planning and preparation became survival strategies as important as physical strength or immediate reaction capabilities. However, tools weren't exclusively for hunting purposes. Scrapers converted hides into soft, workable leather for clothing production. Awls pierced holes for stitching processes, enabling people to sew garments fitting tightly enough to block wind penetration. Within worlds where exposure could prove deadly, abilities to create well-sewn coats or boot pairs remained as vital as any weapon system. Alongside these practical implements emerged something unexpected: artistic expression. Deep within caves, far from solar reach, humans left marks enduring tens of thousands of years. They painted mammoths, bison, and horses with outlines traced in ochre and charcoal pigments. Some scenes remained simple, while others depicted entire herds captured with such careful attention that their musculature and movements still appear alive today. Handprints pressed against walls still remain visible, as if creators were reaching across temporal boundaries, leaving signals of their presence, that they had witnessed these worlds and wanted them remembered by future generations. These artistic expressions represented more than creative impulses. They demonstrated cognitive sophistication and cultural development, occurring simultaneously with technological advancement. Cave art reveals sophisticated understanding of animal anatomy and behavior, suggesting these weren't casual observations but accumulated knowledge from generations of close interaction with Ice Age fauna. Artists understood how mammoth shoulder muscles moved, how bison held their heads while grazing, how horses positioned their legs during different gaits. This knowledge required patient observation and cultural transmission across multiple generations. Color selection and application techniques demonstrate advanced material understanding. Creating ochre pigments required locating specific mineral deposits, processing them through grinding and mixing procedures, then developing application methods that would adhere to cave wall surfaces. Some paintings show evidence of scaffolding or elevated platform usage, indicating organized collaborative efforts for artistic creation. Beyond individual artistic works, cave sites reveal evidence of repeated occupation and cultural continuity. Multiple artistic layers suggest these locations served as important cultural centers where communities gathered regularly, possibly during specific seasonal periods or significant events. Tool manufacturing debris found alongside artistic materials indicates these sites functioned as comprehensive cultural workshops where practical and creative activities occurred simultaneously. Symbolic thinking evident in cave art parallels developments in tool technology. Both required abstract reasoning, visualizing desired outcomes before beginning work, understanding cause and effect relationships, and transmitting complex knowledge through demonstration and practice. These cognitive developments would prove essential for human survival and eventual dominance within post-glacial environments. Bone and antler working reached remarkable sophistication during this period. Hunters created specialized tools for specific purposes: fishing hooks for catching cold water fish, needles for precise garment construction, spear throwers that increased hunting range and accuracy. These implements required understanding material properties, manufacturing techniques, and usage methodologies that could only develop through extensive experimentation and knowledge sharing. Stone tool technology similarly advanced beyond simple cutting implements. Humans developed composite tools combining multiple materials, stone points hafted to wooden shafts using animal sinew bindings, creating weapons and tools superior to any single material alternatives. These innovations required understanding different material properties and how they could be combined effectively. Storage and preservation techniques became increasingly important as communities grew larger and more sedentary. Methods for drying meat, processing and storing plant materials, and maintaining tool inventories through winter periods all required forward planning and resource management skills. These developments laid foundations for more complex social organizations that would emerge as Ice Age conditions gradually changed. Social cooperation became essential for survival in these harsh environments. Successful mammoth hunts required coordination among multiple individuals with specialized roles: curators, hunters, processors, and toolmakers. This specialization allowed communities to develop expertise in different areas while maintaining group cohesion through shared goals and mutual dependence. Cultural transmission mechanisms developed to preserve and share accumulated knowledge. Storytelling around fires served not only entertainment purposes but educational functions, passing survival techniques, geographical knowledge, and social customs from experienced individuals to younger community members. These oral traditions ensured cultural continuity and knowledge preservation across generations. Seasonal planning became increasingly sophisticated as communities learned predicting weather patterns, animal migration timing, and resource availability. Understanding these cycles allowed better preparation for difficult periods and more efficient resource utilization during abundant times. This environmental knowledge represented accumulated wisdom from countless generations of Ice Age inhabitants. Trade networks began developing between distant communities, enabling exchange of materials, tools, and knowledge across vast distances. Obsidian tools found far from volcanic sources, shell ornaments discovered hundreds of miles from coastlines, and similar tool technologies appearing across different continents all suggest contact and exchange between Ice Age populations. These developments occurred gradually across thousands of years, with each generation building upon previous accomplishments while adapting to changing environmental conditions. The combination of technological innovation, artistic expression, social cooperation, and cultural transmission created foundations that would support human expansion and development long after Ice Age conditions ended. Within their firelit shelters, surrounded by tools they had crafted and art they had created, these Ice Age humans were becoming something new, not just survivors, but innovators capable of transforming their environment rather than merely adapting to it. Their legacy would extend far beyond the frozen world that shaped them. No individual can definitively explain their motivations for creating these remarkable artistic expressions. Perhaps these images formed integral components of ceremonial practices, attempts to invoke favorable fortune for hunting expeditions, or to honor the magnificent animals upon which their survival depended entirely. These rituals might have served as spiritual bridges connecting human communities to the natural forces governing their existence, acknowledging their dependence upon creatures they both revered and hunted. Alternatively, these cave paintings may have functioned as educational tools for younger community members, systematic methods of teaching them to identify distinctive shapes, movement patterns, and behavioral characteristics of creatures they would eventually need to track across vast frozen landscapes. This instructional theory gained support from the anatomical accuracy displayed in many cave paintings, suggesting artists possessed intimate knowledge of animal behavior that required transmission to future generations. Yet another possibility emerges that these artistic creations represented fundamental human expressions, the manifestations of an innate creative urge that persisted even when external environments remained harsh and unforgiving. This interpretation suggests that artistic expression constituted an essential human characteristic, appearing whenever communities achieved sufficient stability to engage in activities beyond immediate survival requirements. Carvings also emerged during this transformative period. Small figurines meticulously crafted from bone or ivory materials displayed remarkable skill and attention to detail. Some sculptures depicted animals with extraordinary precision, capturing not merely physical forms but suggesting movement and life force. Others portrayed human figures with varying degrees of stylization and abstract representation. The most renowned among these artistic achievements are the Venus figurines, rounded, stylized representations of human form that have puzzled archaeologists for generations. Their purpose remains enigmatic, yet they demonstrate minds concerned with concepts extending far beyond food procurement and shelter construction. These figurines might have served fertility symbols, spiritual talismans, or even early attempts at personal identification within communities. These artistic expressions represented humanity's initial creative sparks, to evidence that even within glacial shadows, humans carried profound needs to transform abstract ideas into tangible forms. The creation of these objects required not only technical skill but conceptual thinking, suggesting cognitive developments that would prove essential for future cultural advancement. These same innovative minds simultaneously developed sophisticated methods for organizing their social lives. Hunters coordinated their efforts through complex group strategies, mastering techniques for driving animal herds toward predetermined locations where waiting spears could ensure successful kills. They systematically tracked herd movements, developing temporal understanding of migration patterns while creating mental maps of territorial features stored entirely within memory. Around their protective fires, community members shared accumulated knowledge through oral transmission, techniques for stone tool production, methods for hide preparation and garment construction, strategies for selecting safest river crossing points during dangerous meltwater periods. Despite lacking written documentation systems, no crucial information disappeared. Each essential skill transferred from experienced individuals to subsequent generations created unbroken chains of survival knowledge, stretching continuously through harsh climatic conditions. Even fundamental fire-making processes underwent significant evolution. Our early human populations learned not merely maintaining existing flames, but creating fire from raw materials. Using flint and pyrite combinations, they generated sparks within dry tinder materials, carefully nurturing small embers until they developed into steady, sustainable flames. Fire transformed from fortunate accidents captured from lightning strikes or maintained through constant vigilance into controllable technology, completely under human direction. This mastery of fire creation laid foundations for every technological advancement that followed. Controlled fire enabled more sophisticated food preparation techniques, advanced tool manufacturing processes, and extended daily activity periods beyond natural daylight limitations. The ability to create fire on demand represented a fundamental shift from reactive survival strategies to proactive environmental manipulation. However, artistic expression revealed the most profound human transformation occurring during this period. Within flickering torch illumination, cave walls transcended bare stone surfaces to become stages for memory preservation and meaning creation. Surrounded by mammoth and bison imagery, rendered in deep red and black pigments, people could perceive their world not simply as immediate physical reality, but as environments they consciously interpreted and understood. They were no longer merely surviving within Ice Age conditions. They were beginning to define those conditions according to their own perspectives and experiences. Within these quiet spaces protected from wind and snow, initial elements of what would eventually become human culture began taking recognizable form. Tool production became increasingly sophisticated, shelters achieved greater structural integrity, and artistic works displayed enhanced complexity and refinement. Systematically, piece by piece, communities learned bending harsh environmental conditions to their collective will, rather than being overwhelmed by climatic challenges. The development of symbolic thinking represented perhaps the most significant cognitive advancement occurring during this period. Cave art demonstrates abstract reasoning capabilities, the ability to represent three-dimensional reality through two-dimensional imagery, to use color and line combinations for communicating complex information, and to create permanent records of temporary experiences. These artistic achievements required collaborative effort and specialized knowledge. Pigment preparation demanded understanding of mineral properties and chemical processes. Application techniques required developing tools and methods for reaching elevated cave wall surfaces. The consistency of artistic styles across different cave sites suggests cultural traditions being maintained and transmitted across considerable distances and time periods. Storage and curation of artistic materials indicates long-term planning and resource allocation beyond immediate survival needs. Communities dedicated time, energy, and materials to activities that provided no direct nutritional or protective benefits, demonstrating social organization sophisticated enough to support specialized roles and cultural activities. The placement of art within caves suggests these locations held special significance beyond practical shelter requirements. Many decorated caves show evidence of repeated occupation and ritual use, indicating they served as important cultural centers where communities gathered for ceremonial purposes, knowledge sharing, and artistic creation. Musical instruments from this period, bone flutes and percussion devices, suggest artistic expression extended beyond visual arts to include acoustic creativity. These discoveries indicate communities engaged in complex cultural activities involving multiple sensory experiences and collaborative participation. Personal ornamentation objects, carved pendants, perforated shells, and decorated tools demonstrate individual identity expression within community contexts. These items required considerable skill to produce and likely carried social significance regarding status, achievements, or group affiliations. Trade networks evidenced by non-local materials found in cave sites suggest cultural exchange occurred across vast distances. Ideas, techniques, and artistic styles spread between communities, separated by hundreds of miles, indicating communication systems and social connections extending far beyond immediate survival groups. Seasonal gathering sites where multiple communities converged show evidence of large-scale cultural activities, elaborate artistic projects, complex tool manufacturing, and extensive knowledge-sharing sessions. These gatherings required sophisticated planning and resource management while fostering cultural development and innovation. Yet even as human populations learned environmental manipulation techniques, they remained relatively small components within much larger ecological systems. Beyond the protective boundaries of their fires and caves, territories still belonged to magnificent predators stalking the steppes. For people to maintain their precarious positions within this frozen wilderness, they required coexistence with those hunters while sharing identical landscapes and confronting the same harsh, unrelenting environmental conditions. The Ice Age represented far more than a world populated by grazing herds and human hunters carrying spears. It constituted the domain of apex predators, Mars creatures, forged by extreme cold into perfect survival instruments. Traversing frozen plains meant living with constant awareness that danger moved within shadows, its presence as fundamental to the landscape as snow accumulation and relentless winds. Among the most terrifying were saber-tooth cats, whose elongated curved fangs have become iconic symbols of Ice Age periods. These bone and enamel blades could penetrate deeply into prey flesh with devastating effectiveness. These felines weren't constructed for extended pursuit activities. Their limbs were powerful yet compact, bodies stocky with strength concentrated within shoulder and neck regions. They functioned as ambush predators, concealing themselves within low vegetation or along river valley edges until unsuspecting bison or juvenile mammoths wandered within striking range. When attacks commenced, They proved swift and brutal, with fangs penetrating targets before prey could attempt escape. These cats required precise timing and positioning, making them specialists in surprise attacks rather than endurance hunting. Their hunting success depended entirely upon choosing optimal ambush locations and waiting patiently for perfect opportunities. Saber-tooth cats faced unique challenges due to their specialized anatomy. Their massive fangs, while deadly effective, were also fragile and required careful usage to avoid breakage. This limitation influenced their hunting strategies, targeting specific prey species and employing particular attack methods that maximized effectiveness while minimizing risk to their primary weapons. However, saber-tooths weren't the sole hunters inspiring fear throughout Ice Age landscapes. Cave lions, nearly double the size of contemporary lions, prowled mammoth steppes with remarkable efficiency. Unlike solitary saber-tooth species, these magnificent cats likely hunted in coordinated groups, their cooperation providing significant advantages over even the largest prey animals. Visualizing packs of these predators, spreading across snow-covered terrain, their golden coats blending seamlessly with pale lighting conditions, paws moving silently over frozen surfaces, creates images of almost unstoppable hunting forces. Few animals possessed capabilities to withstand coordinated attacks from predators possessing such remarkable size and collective strength. Cave lions represented social predators, whose success derived from sophisticated group hunting strategies. Their large size allowed them to target megafauna that smaller predators couldn't threaten effectively. Pack coordination enabled them to surround prey, cutting off escape routes while multiple individuals attacked simultaneously from different directions. Dire wolves presented another formidable threat, exceeding contemporary wolves in both weight and power. They traveled in extensive packs, their numerical advantage transforming them into among the most deadly forces throughout Ice Age environments. These wolves followed migrating herds across vast distances, systematically wearing down prey through persistent pursuit until exhaustion enabled successful kills. For human communities, dire wolves represented both direct rivals and constant warnings about environmental dangers. Their howling sounds rolling across steppes served as reminders that within frozen worlds hunters never achieved complete safety. These vocalizations carried across miles, alerting other predators to kills while warning potential prey of approaching danger. Dire wolf pack hunting strategies differed significantly from those employed by contemporary wolf species. Their increased size and strength allowed them to target larger prey animals, while their pack sizes often exceeded those of modern wolves. This combination made them particularly effective hunters capable of bringing down creatures that individual predators couldn't threaten. Even smaller predators maintained significant positions within fear hierarchies. Wolverines, fierce and relentless scavengers, could drive away animals many times their own size through sheer aggression and determination. These creatures possessed reputations for fearlessness that made even large predators cautious about confronting them over food resources. Arctic foxes demonstrated remarkable adaptability, darting around hunt peripheries while stealing scraps whenever opportunities presented themselves. Their quick movements and excellent camouflage allowed them to exploit situations created by larger predators without directly competing for resources. Various raptor species circled overhead constantly, maintaining aerial surveillance for opportunities to descend upon remains left behind by terrestrial hunters. These birds served important ecological functions by cleaning carcasses while providing early warning systems about predator activities through their flight patterns and vocalizations. Human populations didn't exist outside these predatory hierarchies. They occupied integral positions within them. When venturing beyond shelter protection for hunting or scavenging activities, they risked encountering these dangerous predators. Single mistakes could instantly transform hunters into prey, creating constant tension and requiring extreme caution during all outdoor activities. This perpetual pressure forced human communities to adopt cautious behavioral patterns, traveling exclusively in groups, maintaining bright fires throughout night hours as both warmth sources and warning signals. Campfire illumination created fragile barriers against darkness, yet proved sufficient for keeping threatening shadows at manageable distances. Relationships between human populations and apex predators encompassed more than simple fear dynamics. They also involved complex competition and mutual respect systems. When early hunters tracked bison herds, they frequently discovered themselves following identical trails used by dire wolf packs. When scavenging mammoth remains, they might arrive to find saber-tooth cats already feeding on carcasses. During these encounters, survival required more than physical strength alone. Success demanded psychological fortitude, understanding when to engage in confrontation, when to retreat strategically, and when to wait patiently for larger predators to complete feeding and depart from areas. Scavenging represented a crucial survival strategy that brought humans into direct contact with apex predators. Large kills provided enormous quantities of meat and materials, but accessing these resources often required waiting for primary predators to finish feeding or finding ways to drive them away from carcasses. Tool development partly responded to predator threats. Spears provided distance weapons, allowing humans to defend themselves without close combat engagement. Fire torches extended protection beyond camp boundaries, while serving as psychological deterrents against nocturnal predators. Territory selection for camps and seasonal settlements required careful consideration of predator activity patterns. Locations offering natural protection features, elevated positions, water barriers, or restricted access routes. Mortars provided defensive advantages against potential attacks. Communication systems developed partly to coordinate responses to predator threats. Warning calls, tracking signals, and information sharing about predator movements became essential survival skills that communities refined across generations. Hunting strategies had to account for predator competition and interference. Human hunters learned timing their activities to avoid peak predator activity periods while developing techniques for quickly processing kills before competitors arrived. Food storage and preservation methods became crucial for reducing exposure to predator encounters. Techniques for caching meat and materials in secure locations allowed communities to minimize dangerous scavenging trips while maintaining adequate resource reserves. Understanding predator behavior patterns provided significant advantages for human survival. Knowledge about seasonal movements, hunting preferences, and territorial boundaries allowed communities to make informed decisions about travel routes and activity. Timing. The constant presence of these magnificent predators shaped every aspect of human behavior during Ice Age periods. They influenced settlement patterns, hunting strategies, tool development, and social organization in ways that would have lasting impacts on human evolution and cultural development. Living alongside such formidable predators required developing psychological resilience and social cooperation that became fundamental characteristics of successful human communities. These challenges forged survival skills and social bonds that would prove essential as humanity eventually expanded beyond Ice Age environments into new territories and challenges. Yet even that final gasp of the Ice Age eventually surrendered to inevitable change. When frigid conditions finally released their grip permanently, glaciers retreated with unprecedented speed. Oceanic waters, nourished by meltwater from countless rivers, commenced their relentless rise. Terrestrial areas vanished beneath advancing waves. Land bridges that had previously facilitated human and animal migration across continents were consumed by expanding seas. Beringia, the enormous tundra expanse that had connected Asian and North American territories, disappeared beneath Bering Strait waters. Doggerland, once a productive hunting territory between Britain and continental Europe, was submerged by the rising North Sea. These weren't gradual processes but relatively rapid geological events that fundamentally altered global geography within centuries rather than millennia. As planetary temperatures increased, forest systems began advancing northward systematically, replacing the magnificent grasslands of the Mammoth Steppe. Tree populations spread across European, Asian, and North American territories, transforming open plains into shadowed woodland environments. This vegetation shift represented more than simple species replacement minds. It constituted complete ecosystem transformation that would affect every aspect of biological communities. Many Ice Age giants, creatures specifically adapted for cold conditions and limitless open spaces, discovered themselves constrained by these changing landscapes. Some species demonstrated adaptive capabilities, many others could not. The specialized anatomical features that had enabled their success in glacial environments became limitations in warming, forested conditions. For human populations, this transformation presented unprecedented opportunities. So as glaciers retreated and climatic conditions stabilized, they discovered territories rich in flowing waterways, fertile soils, and diverse resources previously inaccessible. They followed meltwater flows, establishing settlements near lakes and valleys carved by retreating ice, beginning the extended process of transitioning from nomadic hunters into something entirely different. On the 6, the initial inhabitants of a warming world. Yet even as they adapted to these new terrestrial conditions, glacial influences remained permanently inscribed within landscapes. Glacial valleys became natural highways for river systems. Deposits of sediment and stone became foundations for future agricultural territories. Their retreat marked not only the conclusion of a frigid epoch, but the beginning of the world that would subsequently emerge. The Ice Age wasn't completely finished, but its dominance was broken. Walls of ice that had appeared eternal were dissolving, and in their place new landscapes were materializing. The final great floods remained imminent, bringing with them the ultimate planetary transformation that would establish contemporary geographical features. As glaciers weakened and global temperatures rose, ice didn't simply disappear quietly, it fought its way toward extinction through erratic melting patterns. Sometimes gradually, sometimes through catastrophic releases. Beneath and within diminishing ice sheets, water accumulated in vast concealed reservoirs, restrained by frozen barriers that had existed for thousands of years. When these barriers collapsed, Earth itself seemed to roar with unleashed fury. These weren't ordinary flooding events. They were torrents so immense they rewrote terrain features within days. Throughout North America, one of the most spectacular examples lay beneath the Laurentide ice sheet. As melting progressed, a massive water body known as Glacial Lake Agassiz formed larger than all contemporary Great Lakes combined. For centuries it remained trapped behind ice and terrestrial barriers. However, ice lacks permanence. When containment barriers failed, the lake exploded outward in flooding that would have exceeded human comprehension capabilities. Water surged across landscapes with unstoppable force. Complete valleys drowned within hours. Rivers that had been modest and meandering transformed into raging torrents spanning miles in width. These floods transported boulders as easily as wooden debris, grinding Earth's surfaces while scouring profound channels into bedrock foundations. They poured toward oceanic destinations, elevating sea levels substantially. Through this process, they altered climatic systems themselves. Each flood functioned like planetary system shocks, reshaping wind patterns while redistributing thermal energy across global regions. This wasn't an isolated phenomenon. Around melting glacier peripheries, additional concealed lakes awaited release. Some broke free through violent eruptions, sending water walls crashing across landscapes. Others drained more gradually, their outflows carving new river systems that continue existing today. The Columbia River Gorge throughout the Pacific Northwest exemplifies partial shaping by these glacial outbursts. Floods so massive they tore through terrain repeatedly, leaving behind cliff and canyon landscapes, appearing carved by ancient giants' hands. These geological scars remain visible today, testament to the incredible forces unleashed during Ice Age conclusion. Throughout Europe, similar processes operated extensively. As ice withdrew, meltwater accumulated in basins, forming lakes that eventually overflowed, altering river courses while cutting fresh pathways through terrain. Even within Siberian territories, vast glacial lakes once covered areas now existing as dry plains. Their waters remained secured behind ice walls until barriers broke and contents spilled away. For human populations inhabiting this shifting world, these floods represented both terrifying and transformative experiences. Camps and hunting territories near lake shores would have been eliminated instantly. Valleys once teeming with game vanished beneath rushing waters. Yet in their aftermath, these floods also created new landscapes, fertile plains, and waterway systems that became lifelines for subsequent generations. Even lakes that never experienced catastrophic releases contributed to planetary reshaping. Some remained trapped within terrain for centuries after glacial retreat. Their waters collected in deep scars carved by ice formations. Many Great Lakes we recognize today, the Superior, Michigan, Heroes represent remnants from this period, their basins filled with meltwater as final ice disappeared. These lakes transcended mere geological features. They became biological reservoirs, feeding river systems while nourishing plant and animal communities that would reclaim previously frozen territories. However, not all these lakes achieved permanence. Some were Ice Age phantoms, vanishing as quickly as they appeared, their waters draining away once restraining ice disappeared. Others contracted into smaller forms, their massive shorelines remaining like faded memories etched into Earth's surfaces. For contemporary people, these changes must have created sensations that the world itself was shifting beneath their feet. One generation might mature beside vast lakes with barely visible distant shores. The next generation might discover identical lakes gone, replaced by open grasslands or new rivers flowing where none had existed previously. Within human memory spans, terrain remained alive, changing through methods demanding constant adaptation. Survival strategies developed during stable periods might become obsolete within single lifetimes, requiring continuous learning and flexibility from human communities. These floods and concealed lakes represented not only endings, but beginnings. They transported away final remnants of glacial worlds while carving landscapes of the present. They created river valleys where future civilizations would eventually rise. They deposited fertile plains enriched with sediments from vanished ages. Through their violence and their silence, they marked Ice Age final struggles as it yielded to warmer, more verdant Earth conditions. The rushing waters carried away not only physical materials but entire ways of life, forcing surviving species to adapt rapidly to completely altered environmental conditions. As glaciers retreated and planetary temperatures increased, magnificent Ice Age animals confronted challenges they couldn't overcome. For tens of thousands of years, mammoths, woolly rhinoceroses, giant ground sloths, and saber-tooth cats had dominated their frozen domains. They had achieved perfect adaptation to existence built upon cold winds and endless grasslands. However, the Ice Age was concluding, and with it, their survival foundations began crumbling systematically. Initial devastation originated from changing climatic conditions. As ice sheets melted, the mammoth steppe masked arid grasslands that had supported enormous grazing herds began contracting. Forest systems crept northward, their trees enclosing territories that had once been open and boundless. For creatures constructed for plain environments, this new world proved suffocating. Grasses that had nourished them disappeared beneath leaf canopies, replaced by plant species they were poorly adapted to consume. Mammoths and woolly rhinoceroses could migrate only limited distances before forest barriers blocked their movements. Steppe bison and wild horses, once capable of roaming across continents, discovered their ranges fragmented into isolated patches. Predators, depending on these great herds, dire wolves, saber-toothed cats, and cave lions, witnessed their food supplies diminishing. Gradually, the intricate web of Ice Age existence began unraveling. Each species' loss created cascading effects throughout ecosystem networks, accelerating the collapse of biological communities that had thrived for millennia. However, climate alone didn't constitute the only pressure affecting these giants. Simultaneously, human populations were expanding into every corner of their territories. With tools refined across thousands of years and knowledge transmitted through generations, hunters had become formidable adversaries. Single bands of skilled humans armed with spears could bring down mammoths. Previously rare and dangerous achievements became more frequent, especially as human populations grew and hunting methodologies became more sophisticated. Some researchers argue that hunting alone didn't doom the giants, but rather the combination of hunting pressure and warming climate created perfect extinction conditions. Great animals were already experiencing pressure from shrinking habitats and dwindling food resources. When human hunting intensified, it pushed ecological balance beyond breaking points. Evidence lies scattered across Earth. Throughout Siberia, frozen mammoths remained buried in permafrost, some bearing wounds that could only have originated from human weapons. Throughout North America, mammoth kill sites display clear signs of organized hunts, with bones cracked open for marrow extraction and meat stripped completely. These weren't isolated incidents, but components of larger patterns occurring wherever humans and megafauna encountered each other. Yet even as many giants disappeared, some clung to survival. On remote Arctic Wrangel Island, small mammoth populations survived thousands of years after their relatives vanished from mainland territories. They diminished in size, becoming smaller, weaker versions of their ancestors. However, they endured, isolated from the remaining world by rising seas. Eventually even they disappeared, but their extended survival stands as final echoes of vanished ages. Extinction wasn't swift but occurred in waves, beginning in some regions, while giants still roamed others. Throughout Australia, many great marsupial creatures were gone long before northern ice sheets had begun melting. Throughout the Americas, mammoths and saber-tooths persisted until warming worlds and human expansion reached tipping points. By the time the Ice Age finally yielded to present climatic conditions, great herds had thinned to nothing, leaving behind only bones and silence. This extinction event reshaped Earth as dramatically as melting glaciers. With giant losses, entire ecosystems shifted fundamentally. Grasslands that had once been maintained as open spaces by mammoth and bison herds yielded more rapidly to forest encroachment. Predators that had relied on large prey either vanished or adapted to smaller targets. Humans, no longer sharing terrain with towering beasts, found themselves in quieter, emptier worlds. Still, traces of that wild age remain visible today. Muscans survive in Arctic tundra regions, living fragments of the steppe. The bison continue roaming in smaller herds, their ancestors having endured when so many others failed. Even contemporary elephants carry mammoth echoes in their genetic material. However, the giants who once defined Ice Age periods exist now only in frozen remains, scattered fossils, and faint memories of what Earth once was. Their disappearance wasn't story conclusions, but beginnings of new chapters. With glaciers gone and great beasts fading, the world shifted once more, establishing foundations for planetary conditions that increasingly resembled our contemporary home. The megafaunal extinction represented one of the most significant biological events in recent geological history. It marked the end of an era when enormous animals dominated terrestrial ecosystems, and the beginning of a period characterized by smaller, more adaptable species better suited to rapidly changing environmental conditions. Human populations, having contributed to these extinctions, also inherited the consequences. The loss of large game animals forced human communities to diversify their subsistence strategies, leading to increased reliance on smaller animals, plant resources, and eventually agricultural development. This transition would prove crucial for human cultural evolution and the development of complex civilizations. The extinction patterns varied significantly across different continents and regions, reflecting local environmental conditions, human population densities, and species vulnerabilities. Understanding these patterns provides insights into contemporary conservation challenges and the ongoing impacts of human activities on global biodiversity. When the final great beasts faded and glaciers withdrew permanently, the world commenced transformations that would have been unrecognizable to those who had experienced Ice Age peaks. What had once been a frozen, wind-swept planet of ice and dust began softening dramatically. Sharp edges carved by glaciers yielded to gentler forms. Rivers swelled with meltwater, forests advanced systematically, and Earth began slow transformation from white to green. Warming wasn't sudden, yet its effects appeared everywhere. Vast ice sheets that had dominated northern continents for tens of thousands of years contracted toward polar regions. In their absence, valleys opened, plains stretched widely, and scars left by retreating glaciers filled with meltwater. These new lakes became anchors for biological systems, their shores lined with initial green shoots of plants reclaiming territories. This period marked the transition from Pleistocene to Holocene epochs, from Ice Age conditions to the relatively stable, warm climate that has characterized the past 10,000 years. This climatic stability provided the foundation upon which human civilizations would eventually develop and flourish across all continents. The Ice Age legacy remains inscribed within contemporary animal lives as well. Bison continue roaming North American plains, descendants of herds that once grazed alongside magnificent mammoths across endless frozen steppes. These powerful creatures carry within their genetic material the evolutionary adaptations forged during millennia of harsh glacial conditions. Thick winter coats, efficient metabolism for processing sparse vegetation, and behavioral patterns developed for surviving extreme weather events. Musk oxen, shaggy and unyielding, persist throughout Arctic tundra regions, virtually unchanged from their Ice Age ancestors who weathered the harshest conditions Earth could produce. Their dense double-layered coats, defensive herding behaviors, and ability to survive on minimal nutrition represent evolutionary solutions, perfected during glacial periods when survival margins were razor-thin. Reindeer and caribou, undertaking annual migrations across northern territories, follow pathways carved not merely by instinct, but by memories older than recorded human history. Roots rooted in the age of ice and perpetual wind, these migration corridors, established when sea levels were lower and land bridges connected, now separated territories, continue guiding these animals across landscapes that have been fundamentally altered since their ancestors first traveled these paths. Arctic foxes demonstrate remarkable adaptations inherited from Ice Age survival strategies. Their seasonal coat color changes from brown to white, their compact body shapes for heat conservation, and their ability to locate prey beneath snow represent evolutionary refinements developed during periods when such capabilities meant the difference between survival and extinction. Polar bears, though evolved more recently, carry genetic legacies connecting them to Ice Age survival strategies. Their specialized hunting techniques, incredible insulation systems, and ability to fast for extended periods reflect adaptations that originated during glacial periods when environmental conditions were even more extreme than contemporary Arctic conditions. Even within us, these echoes remain deeply embedded. Human migrations were fundamentally guided by Ice Age world configurations. Our ancestors crossed land bridges, exposed by dramatically lowered sea levels, followed migrating herds across the mammoth steppe, and mastered survival techniques in cold conditions that would prove fatal to unprepared individuals. Skills forged during that transformative period, and creation and control, sophisticated tool manufacturing, complex social cooperation, none didn't disappear with melting ice. Instead, they became foundational elements of everything that followed in human cultural development. These survival technologies, refined through countless generations of Ice Age living, provided the technological and social foundations upon which later civilizations would be constructed. Contemporary human genetic diversity patterns still reflect Ice Age migration routes and population bottlenecks. DNA studies reveal how glacial periods forced human populations into isolated refugia, creating genetic signatures that persist today. The geographic distribution of certain genetic markers traces pathways our ancestors followed as they navigated between ice sheets and across exposed continental shelves. Archaeological evidence demonstrates that Ice Age survival strategies influenced human development in profound ways. The necessity for long-term planning during harsh seasons fostered cognitive developments that would prove essential for agricultural societies. Cooperative hunting techniques refined during mammoth hunts established social organizational patterns that scaled up into complex civilizations. Language development may have been accelerated by Ice Age survival requirements. The need for precise communication during dangerous hunts, complex tool-making instructions, and detailed environmental knowledge transmission likely drove linguistic sophistication that provided advantages for post-glacial human expansion. In contemporary landscapes we cultivate, within river systems we depend upon, and throughout coastline configurations we inhabit, Ice Age influences remain omnipresent. Valley systems carved by glacial action became natural corridors for transportation networks. Fertile soils created by glacial grinding and deposition support modern agricultural systems. Lake systems formed by glacial activity provide water resources for major population centers. River patterns established during glacial periods continue determining where cities develop and how transportation networks evolve. The Great Lakes carved by Ice Age glaciers remain crucial for North American commerce and freshwater resources. European river systems, redirected by ice sheet advances and retreats, continue influencing political boundaries and economic development patterns. Coastal configurations shaped by Ice Age sea level changes determine contemporary port locations, fishing grounds, and marine ecosystems, Underwater geological features created during periods of lower sea levels continue influencing ocean currents, which affect global climate patterns and marine biological productivity. Within animals that still inhabit the coldest planetary regions, and within fossilized remains buried beneath our feet, Ice Age presence never truly disappears. It shaped Earth's physical structure, and in numerous ways it shaped human development as well. The fundamental relationship between environmental challenges and evolutionary innovation, established during Ice Age periods, continues driving both natural and cultural evolution. Perhaps the most striking echo involves recognizing how rapidly our world can transform. Complete ecosystems emerged and vanished. Ocean levels rose and fell dramatically. Giants inhabited Earth, then disappeared forever. Throughout these massive changes, life demonstrated remarkable adaptability. It survived catastrophic alterations. It discovered innovative pathways forward. The frozen world may have concluded, but its narrative continues. It persists within ground, beneath us, within fossils we uncover, and throughout landscapes extending around us. The Ice Age transcends being merely a historical chapter. It represents the prologue for our present reality. As we transition from these echoes toward the contemporary world we recognize, we can finally step back and observe the complete scope of that frozen epoch. From its initial creeping cold through its final lingering traces, the Ice Age represents one of Earth's most transformative periods. If you could journey back into Ice Age conditions now, progressing step by step beyond present-day forests and rivers, into that frozen world, the initial sensation you would notice would be the profound quiet. Wind would continue moving, and snow would still fall, yet beneath it all would exist deep stillness, the kind that emerges only when time itself seems stretching wider than imagination can encompass. You would observe horizons opening into vast plains where sky appears larger than Earth below it. You'd witness mammoth herds moving slowly across steppes, their breath rising in clouds against pale atmospheric conditions. Throughout distances, bison would graze in formations that seemed extending forever. Far beyond them, faint predator shapes would follow moorish, silent and patient. Cold would bite exposed skin, yet the world itself would feel alive through methods difficult to experience today. A world of raw, unfiltered magnitude where every environmental element demanded respect and understanding. This wasn't a landscape softened by human intervention, but nature in its most honest, uncompromising form. You might pause beside glacial edges, their walls rising like frozen cliffs with blue ice gleaming where sunlight struck surfaces. Water would trickle down faces in thin streams, beginnings of rivers that would eventually carve pathways across entire continents. The sound would be low and steady, reminding observers that even the mightiest ice walls never remain truly motionless. They breathe, shift, and eventually release their contents. Turning away from ice toward inhabited territories, you'd discover traces of human existence. Small circles of dwellings constructed from bone and hide materials, smoke rising from central fires. You'd observe footprints in snow, tools arranged for sharpening, and hunters returning from distant horizons, their faces marked by wind and sun exposure. These people would regard identical frozen terrain, not with wonder but with familiarity. For them, this wasn't distant prehistory. It was home Sid, the only environment they had ever known. Their survival strategies, social organizations, and cultural practices were perfectly adapted to conditions that would challenge any modern individual's survival capabilities. Walking through this world would reveal Earth in one of its most honest forms. No urban centers, transportation networks, or artificial barriers existed. You'd only nature's slow, patient work of carving and shaping everything across millennia. The Ice Age wasn't a frozen prison constraining life, but rather a teacher and sculptor that in its own way represented a beginning rather than an ending. Even though that world has vanished, its presence never truly departed. It lingers within valleys and lakes carved by its glaciers, within soil systems that nourish our crops, within animals that continue inhabiting the planet's coldest regions. It lives within our own history, within fires our ancestors built and tools they carried across endless snow. Standing outside during winter nights, when air is sharp and the world remains still, you can almost sense it. Money that isn't personally yours yet feels familiar. This sensation is written within stones beneath your feet, carried within wind currents, whispered by the quiet weight of time itself. The Ice Age transcends something we simply left behind. It represents something that shaped the ground we traverse and the lives we experience. Its story is inscribed into the world itself. If you listen carefully enough, it remains there, Mayamos, faint but steady, like footsteps preserved in ancient snow. Contemporary climate research reveals that Ice Age cycles continue influencing current environmental patterns. Ocean circulation systems established during glacial periods continue affecting global weather patterns. Deep ocean water masses formed during Ice Age conditions continue influencing marine ecosystems and carbon cycling processes. Atmospheric composition studies show that gases trapped in ice cores provide crucial data for understanding contemporary climate change. The natural climate variations documented in Ice Age records help scientists distinguish between natural climate fluctuations and human-induced changes. Geological research demonstrates that Ice Age processes continue shaping landscapes through post-glacial rebound, continued erosion of glacial deposits, and ongoing adjustments to river systems established during glacial periods. Understanding these processes helps predict future landscape evolution and geological hazards. Archaeological discoveries continue revealing new information about human adaptations during Ice Age periods. Recent findings suggest that human technological and cultural innovations during glacial periods were more sophisticated than previously understood, providing insights into human cognitive evolution and cultural development. Paleobiological research into Ice Age extinctions provides crucial perspectives on contemporary biodiversity loss. Understanding the factors that led to megafaunal extinctions helps inform current conservation strategies and predict ecosystem responses to ongoing environmental changes. As we leave this frozen world behind, we carry it with us through every aspect of our contemporary existence. Every glacier that once dominated landscapes, every herd that migrated across ancient steppes, every isolated camp where our ancestors survived harsh conditions has contributed to this present moment. The Ice Age has concluded, yet its story remains etched into Earth's structure and into our very beings. When you observe contemporary terrain, minute rivers flowing through valleys, hills rising from plains, quiet expanses of sky extending to distant horizons, you're witnessing its legacy made manifest. These aren't random geographical features, but carefully sculpted landscapes shaped by forces we can barely comprehend. Each valley represents thousands of years of glacial carving. Each lake fills depressions ground out by ice sheets. Each fertile plain rests upon sediments deposited by ancient floods. When you experience winter winds chill penetrating clothing and reaching skin, you're connecting with something ancient pills, a faint echo from worlds where survival constituted the only universal language and snow never truly ceased falling. That cold carries within it memories of ancestors who faced far harsher conditions with primitive tools, yet somehow persevered through innovation, cooperation, and sheer determination. We inhabit a different age now, characterized by warmth, rapid change, and unprecedented human influence over natural systems, yet we remain fundamentally shaped by the epoch that preceded ours. Our cognitive capabilities, social structures, and technological foundations all trace their origins to survival challenges faced during glacial periods. Understanding this connection provides perspective on our contemporary position within ongoing planetary narratives. We exist not as separate from natural history, but as its continuation. Our cities rise within valleys carved by ice. Our agriculture depends upon soils ground by glaciers. Our freshwater resources flow through lake systems created by glacial activity. Climate scientists studying Ice Age records discover that our planet's climate system operates through complex cycles spanning thousands of years. Current global warming occurs within the context of these longer-term patterns, though human activities are now influencing these natural cycles in unprecedented ways. The Ice Age never truly concludes. It persists within stone formations recording its passage, within water systems it established, within genetic memories of surviving species, and within the quiet spaces where careful observers can still detect its presence. If you pause sufficiently long to listen, truly listen, it remains there, waiting to share its ancient wisdom about survival, adaptation, and the patient work of time itself. Archaeological evidence continues revealing that Ice Age human populations were far more sophisticated than traditionally assumed. Recent discoveries of complex tool technologies, artistic achievements, and social organizations suggest that glacial period challenges accelerated rather than hindered human development in crucial ways. Genetic research demonstrates that Ice Age population dynamics continue influencing contemporary human diversity patterns. The genetic bottlenecks, migration routes, and adaptation strategies established during glacial periods created foundations for modern human geographic and cultural diversity. Environmental restoration efforts increasingly recognize the importance of understanding pre-human baseline conditions. Ice Age ecosystem structures provide models for conservation efforts, attempting to restore natural processes and species relationships that developed over thousands of years. Educational initiatives focusing on Ice Age history help contemporary people understand the deep time scales within which current environmental changes occur. This perspective provides context for addressing climate change, biodiversity loss, and other contemporary environmental challenges. The story of the Ice Age ultimately reminds us that our planet has experienced dramatic changes throughout its history. Continents have shifted, climates have oscillated between extremes, and life has repeatedly faced extinction events, followed by remarkable recoveries and innovations. Yet within this vast temporal context, the Ice Age represents something uniquely relevant to our current situation. It was the period during which modern humans developed the capabilities that allowed our species to eventually dominate planetary systems. The tools, social structures, and cognitive abilities developed during Ice Age survival challenges provided foundations for everything that followed. As we face contemporary environmental challenges, climate change, species extinctions, resource depletion, the Ice Age offers both warnings and inspiration. It demonstrates that dramatic environmental changes can occur relatively rapidly and have profound consequences for all life forms. It also shows that life possesses remarkable resilience and capacity for adaptation when faced with seemingly insurmountable challenges. The frozen world that once dominated our planet exists now primarily in memory and evidence, but its influence continues shaping every aspect of our reality, from the ground beneath our feet to the patterns of our thoughts, from the rivers that sustain our cities to the genetic codes that define our species. The Ice Age remains present within our contemporary world. In recognizing this connection, we gain perspective on both our capabilities and our responsibilities. We are the inheritors of survival strategies developed over tens of thousands of years, yet we also possess the power to influence planetary systems in ways that our ancestors could never have imagined. The Ice Age teaches us that change is constant, adaptation is essential, and cooperation is crucial for survival during challenging periods. These lessons, learned by our ancestors around fires burning in the endless cold, remain relevant as we face the challenges and opportunities of our own rapidly changing world. The story continues, written now not in ice and stone, but in the choices we make and the futures we create. The Ice Age may be over, but its most important lesson endures. Life finds a way forward, no matter how difficult the circumstances, through ingenuity, persistence, and the quiet courage to continue when the path ahead seems uncertain. In the end, we are all children of the Ice Age, shaped by its challenges and inheritors of its hard-won wisdom. As we move forward into an uncertain future, we carry with us the knowledge that our species has faced seemingly impossible circumstances before, and found ways not just to survive, but to thrive and eventually reshape the world itself. The Ice Age whispers to us still, reminding us of where we came from and suggesting possibilities for where we might go next.